Welcome back. Great to see you here again. My name is Luc de Ceuster, founder of the Ceuster Academy, and we have a new interesting video for you. This video is about the conversion between binary numbers and hexadecimal numbers and vice versa. But before we start with the video, do not forget to click the subscribe button if you didn't do it yet. Click on the bell button so you will be informed every time we have a new video. But let's have a look at the topic of this video. We're talking about binary to the hexadecimal format. So we're transforming binary numbers in hexadecimal numbers. And that's something which is very important in computer science because hexadecimal numbers are a lot shorter than binary numbers. They're basically a condensation of it, and we're going to use the same methods. Like I said before, we have decimal numbers can be expressed as a product of powers of two, a sum of powers of 2, or they can be expressed as a sum of powers of 16. The coefficients for the binary numbers are either 0 or 1. And for the hexadecimal numbers, they go from 0 up to 16, 16 not included. Now, in order to avoid problems between the numbers, we cannot write the numbers larger than 9 in their decimal form. So in the hexadecimal format, and that's how you can recognize very easily a hexadecimal number, is that the decimals larger than 10 are represented by letters of the alphabet. 10 is equal to A, B is 11, 12 is equal to C, 13 is D, 14 is E, and 15 is F. So basically that's what we're going to do. We're going to do the same thing we did with the previous numbers, with the octal numbers, but now the highest number that we want to represent, the highest coefficient, is 15. And 15 is in binary 1, 1, 1, and 1. What we're going to do now is grouping the binary coefficients in groups of 4 and identifying the powers of 16 in those groups. Let's have a look at these groups here. So we have the first group of 4, the second group of 4, the third group of 4, and here we have nothing in front, so it means that these are zeros. So we have 0, 0, 0. We always start to write a binary number from the first coefficient different from 0. Now what we're going to do now, we have to identify the powers. So here we have 16 to the power 0. Here we have 16 to the power 1. We have 16 to the power 2. And here we have 16 to the square. And like we did in the octal numbers, we are going to calculate the value of the coefficient by transforming this binary number into a decimal number. And 1, 1, 1 is 1 plus 2 plus 4. So we have here 7. 4 plus 2 is 6 plus 1 is 7. Here we have 4 and 2. This is 6. Here we have 8 and 2. So this is 10. But we know that 10 is represented by A. And this is 1. So what we can say here is that this number is equal to the hexadecimal number 1A, 6, 7, and 16. Now, we always take the habit to put the 16 there, but since we have an A here, we can identify immediately that this must be a hexadecimal number. But it's not always the case. It can be a decimal here. For example, if it was one number less, it would be 1967. But it could be a decimal number. It could be an octal number. cannot be a binary number, but it can also be a hexadecimal number. So it's very important to have the coefficient there. But let's do another exercise. Let's have another look at another example of a transformation of a binary number into a hexadecimal number. Do you see what is missing? Have a look. I forgot something. Can you identify it? Well, it's quite simple. I didn't put the 2 here. So in order to be sure that we know that this is a binary number, I put the index 2 there to indicate that this is a number base 2. The only exception are, in general, the decimal numbers. Or when we're just working, we know that we're working in a specific base, then we can leave the base away. But in these exercises, we have to be clear to indicate what base we are using. We split everything in 4, so we have the first 4, the second, and here again those 4, and we see no zeros here, so I can put here 2 zeros to complete the sequence to have 4 binary numbers for each set. So when we look here, we have 16 to the power 0. We have here 15. So we have to say 15 is equal to f. Here we have 16 to the power 1. We have 8 plus 4 is 12. 12 is equal to c. Here we have 16 to the power 2. We have here 4. And we have 16 to the power 3, which is 1, and 2, which is 3. So the final result here of this number, this binary number, is in fact the hexadecimal number of 3, 4, C, F in base 16. So that's the second example of the conversion between a binary number and a hexadecimal number. Let's do the conversion in the other direction from a hexadecimal number into a binary number. And we can try it with this one immediately. Basically, we can write here, this is 15 times 16 to the power 0. We have here C is 12 times 16 to the power 1. Here we have 4 times 16 to the power 2 and 3 times 16 to the power 3. And basically what we do, the last thing that we do, is to translate those coefficients into binary numbers. So we have here 1, 1, 1, 1. We have here 1, 1, 0, 0. We have here 0, 0. Sorry, it has to be 4. So we have 0, 1, 0, 0 and 0, 0, 1, 1. And when we look at it, when we compare those two numbers, they're identical. But let's look at another exercise. Let us consider this number when we look at it, the hexadecimal number A23FB, index 16, to clarify, to show that this is really a hexadecimal number, but we could deduct it immediately because we have A, F, and B in it. What does it mean? So we have power 0, 16 to the power 0, 1, 2, 3, 4. So we can say this is A times 16 to the 4th power plus 2 times 16 to the 3rd power plus 3 times 16 to the square plus F times 16 to the 1 plus B times 16 to the power 0. Now we know that A is equal to 10. We know that F is equal to 15 and B is equal to 11. So basically what we can write here is 10 times 16 to the power 4 plus 2 times 16 to the power 3 plus 3 times 16 to the square plus 15 times 16 to the power 1 plus 11 times 16 to the power 0. And what we're going to do now is to transfer those coefficients in binary notation. We know for 10, this is 1, 0, 1, 0. For 2, we have 0, 0, 1, 0. For 3, we have 0, 0, 1, 1. 15, we have 1, 1, 1. And the last one, 11, is 1, 1, 0, 1. So basically, at the end, we can write that our number here, A, 2, 3FB in hexadecimal, is 1, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 0, 1 in binary notation. And you see that the hexadecimal number is a lot better readable than the binary equivalent. Now, when you look at hexadecimal numbers, you may find them in computers where you have MAC addresses of the different ports of the different elements of your computer, and I'm sure you've already seen it. But let's do another exercise so you get really the knowledge that you really know how to do these transformations very quickly and without errors. This is the last exercise we're going to complete in this video, and we are going to find the binary equivalent of the hexadecimal number 2F21D. Now we have here 16 to the power 0, 1, 2, 3, 4. So we can write this number as B times 16 to the 4th power plus F times 16 to the 3rd power plus 2 times 16 to the square of to the 2nd power, 1 times 16 to the power 0 plus D times 16 to the power, this is 1 and this is 0. Now what we're going to do, don't forget, B is 11, F is 15, and D is equal to 13. What we're going to do now is to write the binary equivalents of those coefficients. So the first one here for B, 11 is 1, 1, 0, 1. For F, it's 1, 1, 1, 1. For 2, we have 0, 0, 1, 0. For 1, we have 0, 0, 0, 1. And for 13, we have 1, 1, 0, 1. So basically, now we have the equivalence between the two numbers. So I can say BF21D in hexadecimal notation is equal to 1101, 1111, 0010, 0001, 1101 in binary notation. So in this video I try to explain to you how you can do the conversions between binary and hexadecimal numbers and vice versa. That was it for this video. Don't forget to have a look in the description. Under the video you have a lot of links for interesting courses offered to you by the Ceuster Academy. You can find them on our website, theceusteracademy.com, and look at the prices, look at the coupons that you get, because with the coupon you get a really great discount. And like we're at the end of the video again, do not forget to subscribe to our YouTube channel if you didn't do it yet. If you still have to subscribe, click on the subscribe button, click on the bell button, and I'm looking forward to seeing you in our next video. Thank you and bye-bye.